Okay, so to get to our speakers today, we have Andy Wick, who is the creator of Arkime, formerly Moloch. It's gone through a sort of a renaming here in the last few months. And Elyse Rinne, hopefully I pronounced that right. Elyse, sorry if I didn't, who is a UI, I'm sorry?
Rinne.
Rinne, okay. So Elyse Rinne, who was a UI and full stack engineer. And with that, I want to thank you both for joining us today. Really excited to learn more about Arkime from those that know it best. I've been a longtime user of Arkime, and so really excited for this. I'll stop my screen share and hand it over to you guys.
Great, thanks, Josh. Let's see. All right, are we good?
Looks good here.
Okay. So just real quick to continue the introductions, I created Arkime back in 2011, 2012. I joined the security team at the same time. Prior to that, I was working on AIM, mostly the back end part of AIM, but I did some of the client work. And then Elyse joined the team back a few years ago, really to fix the terrible UI that I had done for Arkime because it was awful. And since then, she's taken over a lot of the middleware, does most of the UI, and just in general fixes all the bugs that we create. So she's been a great addition to the team. We're both employed by Verizon Media, which used to be AOL, then became part of Verizon, then became merged with Yahoo, then became Verizon Media, and recently we may be spinning back out to Yahoo, but they have supported us ever since the beginning to create this tool.
Hey, Andy, sorry to interrupt. You've got a couple of gray boxes overlaying your screen. Do you have any Zoom components or anything on top of your presentation?
I do. Should I just hide those?
Yeah, I think so. Those come through as big gray boxes on your screen.
Is that better?
It's minimal now. They're still there, but they're minimal.
I don't know how to make them go away.
Okay. It should be better. So
where is it? Like on the right?
There's the very top. That's pretty minimal now. And then you've got a little one off to the right. Yeah.
Yeah, that's where it says you're talking. I don't know how to get rid of that.
Oh, okay. I'm not sure either.
Oh, I can drag it.
Oh, that's good. Is
that good?
That's better. Yeah, it's up in the corner now.
Okay.
Okay, thanks.
Cool. Yeah, and feel free, anybody, to stop us and ask questions. Okay, let's kind of talk about the story of a user here. So we have an end user sitting at home, using their laptop. They're surfing their web. They're searching for stuff. So here we're searching for owls because owls are awesome. And that's our logo. And everything's good. But then all of a sudden, you know, they hit a site or something where it's downloading a Trojan horse, or there's some malware or a rat to their computer. And, you know, how can we see what's going on? And that's where the visibility stack, or the network visibility stack, plays a role. And that's what we're going to be talking about today, is network visibility, how it's sitting in the middle, watching the traffic as it goes by. And there's several different tools that can be used. Suricata, Arkime, and Zeek are three of the ones that we use. And it's going to be watching the traffic, looking for things, and it'll forward alerts and other things off to the teams at either your company or organization that are watching the traffic. And they probably have a SOC or an IR or other teams in the security world that will help figure out what's going on. And so how do we build this network visibility stack? And we're going to focus mainly today on Arkime. So Arkime, formerly Moloch, and we changed the name back in the beginning of, or the end of 2020, is a full packet capture system that's open source. So that gives you complete control of what you want to do. Just like Suricata and Zeek are open source and give you complete control around IDS and other things, this gives you complete control over the deployment of full packet capture. We use Elasticsearch for our database of the metadata, and that's what powers all of our searching. And the actual packets themselves are stored to local disk, usually in standard PCAP format, although we support other things such as encrypted formats. And it was really built to replace a commercial full packet capture system that was just too expensive, and it didn't let us have control. We've deployed Arkime in huge settings, supporting over a terabit a second of processing. And so it can really scale across as many boxes as you want. So what do we mean by the network visibility stack? Well, to us, it means you have these boxes that are running different software that are monitoring the traffic as it goes by. And you put these boxes at key network points that can watch the traffic as it goes to and from, in our case, the internet. This is really where we're focused, although other people focus inside their data centers or colos, but our main focus has always been what's sometimes called north-south traffic, or basically just traffic that's going to and from the internet. And of course, the internet is in quotes because everybody defines what that actually means differently. But to us, it means they're going to sites that we don't control.
Hey,
One
Andy,
of the most
quick question.
Sure.
So a question from Kumar. How is the scenario in boundary-less cloud environment?
Yeah, so in a cloud, you still have, and even in, so this is a great question, both cloud and, oh my gosh, I'm blanking all of a sudden. What is the zero thing? Zero.
I'm blanking too.
Anyway, the zero thing where I'm blanking on the thing where you don't actually have, kind of logical controls. You still have physical controls, right? You still kind of have the traffic is still flowing through a general network endpoint. And in the cloud, especially AWS now, which allows you to mirror the traffic, you can still watch from a central location what's going to and from the quote unquote internet. And inside your VPC or inside, I can't remember what Google calls it, you can ignore that traffic, or you can filter it out based on IPs, or there's a bunch of different strategies that you can do. But there's still kind of a choke point that your traffic is going through. It is harder in the cloud, but it is possible, especially with AWS. They've really added a lot of features. And I think Google is catching up. I don't know where Microsoft is currently, but I don't know if that answered the question.
I'll let you know if there's any follow-up. Great, thank you.
Great.
And a lot of comments, zero trust or zero
trust,
client?
thank you.
Yeah, zero trust. Okay, we got it.
I was totally blanking. Yes, so even with zero trust, everybody comes to me and goes, oh, zero trust, this is gonna fail. It's like, if you're doing zero trust in a data center, you still have the physical links going to quote unquote the internet, right? So those still can be monitored. Yes, you may not have your firewalls and other things in a zero trust, or the firewalls work differently. You're still physically have traffic going over a line. It doesn't magically, skip that because you're in zero trust. Cool. So an important thing for full packet capture is sometimes you actually don't want to capture everything. So it's a little bit of a misnomer. A great example is TLS. If you're not decrypting your TLS traffic and you're leaving it encrypted, really only the first, like, let's say 30 packets or so where you're doing your handshake, the client hello, server hello stuff is useful. And the rest of it, you don't actually have to capture. And so Arkime and other full packet capture tools out there have ways to not capture that traffic. Another great example is security cameras. I was shocked by this, but when we first deployed in some offices, our traffic level was insane. And then we went and looked at these 4K security cameras that are just broadcasting an insane amount of traffic. So again, with those, you may want to only capture the first 100 packets of each session, just so that you don't capture way too much. And then sometimes there's traffic that you don't want to capture. So a great example is if you run like a consumer email service, you may or may not want to capture all of that from a security point of view, because one of the reasons is the mail team probably has a whole bunch of other tools that are better than any of our tools dealing with spam and attacks and other things. So that might be an example of something where you won't want to do full packet capture. So common components, at least for us, we have Arkime, full packet capture, Suricata is our IDS, Zeek, and NetFlow. I like to talk about NetFlow because a lot of people don't actually give it much attention. NetFlow is a great security tool. It's especially good if you actually keep it long-term. I know a lot of organizations throw it away, what I consider way too early. NetFlow should be the last thing that you throw away. And it's very cheap to store, especially if you use some of those tools out there that can compress it and store it in a binary form. And you don't have to have it easily searchable, but it's a great last resort tool. We actually run all of these components on the same machines, our visibility machines. Oops. And I'll be talking about that in a little bit. So some of the pros and cons and why we really like full packet capture is it's the source of truth. It is everything that's going over the network. You can later go back and see what happened. You can run further analysis. You can run new rules. You know, it's been the case where maybe there's a new Suricata rule coming out that you want to run against certain traffic to see if it would have fired or not. Or you can use it to test new rules by going against old traffic. You can look at traffic that's around anything that alerted instead of just the alerted thing. And it's just pretty powerful. It is a little bit costly. It does have kind of an inherent security problem because now you've captured everything. And if hackers can get on the full packet capture system, they can see what's going on. So you need to make sure you take security into account. Definitely TLS and encryption, you know, taking over the world has made it not as useful as it used to be, but it's still useful to see all those TLS connections that are going out. You can see all the certs that are using the SNI. You know, TLS 1.3 is going to definitely make this harder, especially with encrypted SNI, but there's still things you can do, such as the JAW3 fingerprinting, the server fingerprinting. There's still a lot of information out there. And there's still lots of protocols and traffic out there that isn't encrypted. So it's not like just because we're going to encryption for so many things that full packet capture becomes less useful. It's just that there are pieces that will be harder to figure out what's going on. So I've been babbling a little bit, so we're going to go through a quick demo here that Elyse is going to do. One of the things I want to point out is this demo actually fires from an alert from a host endpoint agent, but you could think about it as if this had fired from a Suricata or Zeek alert. So really, just because this demo is using it, the starting point is a alert from a host endpoint agent, that doesn't really matter so much. It's just the whole process of how you use Arkime and what you can do once you have an alert.
Yeah, and hopefully this will give you kind of a better understanding of how Arkime can be used, a real world example of how an alert can be investigated using Arkime. And like Andy said, this could be any alert. So let's go to the next slide, Andy. This particular use case was a CrowdStrike alert, and this local IP reached out to this remote IP during this time range, and then this shell script was run. So this particular alert was out about this bad gopair.far file that was suspicious. So next slide. The easiest way for our incident response team to investigate this alert is to use Arkime. Arkime has all the sessions that contain this file as well as the surrounding sessions. So the incident response team opened up Arkime and searched for this remote IP. So they wanted to see who all connected to this remote IP that downloaded this suspicious file. So to start, they're going to use a search bar, and this allows a user to type a search expression. They're going to search for that destination IP that we were talking about that was able to download this file. It's a type ahead, so a user can create a rich query without having to memorize a bunch of things. It auto-completes field names, operators, and field values. So for the purpose of this demo, it's already restricted to the time range from the alert. And we can see there is only one session that reached out to this IP. So we're lucky. We didn't have a bunch of IPs that were, a bunch of endpoints that were reaching out to that IP. So next, an analyst is probably going to want to dive further, and they're going to pivot on that source IP that was part of the alert. They're going to want to see what that endpoint was doing at this point in time. And this kind of goes back to what Andy was saying, how you can view what was happening before and after the alert, not just the alert traffic itself. Each field value has a little drop down of actions that you can use. The analyst this time is going to want to pivot. So they're going to click on open a new sessions tab, and then this is just going to restrict the search to that source IP. We still have 317 entries from 121 billion. So we're going to narrow down that search even further to just large sessions, because we know that gopair.var file was just was a large session. So here we can see this is where that file was downloaded, and we're probably going to want to dive even further and view what exactly was happening during this session. Next slide, Andy. So to do that, they can open the session metadata and view its metadata and packets. They're going to open that dropdown again, or they're going to open the session on the left with the little plus button. We have session details sectioned into sections. We have the general session for all sessions. And then this was an HTTP session, so you'll see the HTTP session metadata. And if you go down even further, you will see the reassembled packets. The analyst went through this session and they found this area that does not look like what it should. This is not part of the gopair.var normal file. This is some obfuscated code that to the analyst looked like not the right thing. So they went ahead and they reached out to the PEAR team, and they were acknowledged in this tweet that indeed they did find a bad file. This was not the file that normally should have been downloaded when requesting the gopair.var file. Next. So in order to investigate this further and kind of find a timeline of when this gopair.var file was downloaded, the last time there was a good download, so they could kind of create a timeline for people to search about, they're going to use Arkime again to pivot on that gopair.var URI. So they're going to open up that drop-down menu again, and they're going to search for that particular URI, remove the source IP. So they're looking for any IP that downloaded this file, and then create a larger time range. So we're searching for about a week of sessions here. And it looks like there were two files. The first one was the previous bad one, and this one we're going to open up. We're going to scroll down and see what these packets look like. And the analyst scrolls down and they see, okay, this is what we do expect. This is the normal gopair.var download. So this allows the analyst to determine that there was indeed a good download at this time, and it creates a timeline for other users to be able, or for other companies and incident response teams to be able to create a timeline for the incident and find if they also downloaded a bad version of that gopair.var file. So this is just a real world example about how an alert can be used to investigate the traffic surrounding it and figure out what happened and validate the alert. So now that you have kind of a better understanding of how you can use Arkime, Andy's going to show you how we integrate and use Suricata in our visibility stack.
I'm going to jump in if you don't mind. There's a couple questions.
Sure.
And maybe this will tie into what you're about to discuss. So the first question is, do you use Suricata for flow collection or something like Silk NF dump? Both. What do you do when you run multiple tools on the sensor?
Right, so I'll answer the second part first. So we run all of our tools on the same box. We use AF packet for all of them. With Zeek, that requires a plugin. Hopefully someday it will be mainlined. The rest of the tools all support AF packet natively. We have used different flow collecting tools over the years, from NF dump to commercial ones to, I can't remember the one we're using currently, but it just depends. Depends what we're doing and how large the box is and what folks want. One of the tools we've used actually does, I can't remember what they called it, maybe extended NetFlow, where they added a few extra fields. And that's the one we're currently using.
Okay. And second question, let's see, incident handling is aftermath and the IR team works after incident happened. What's the strategy to deploy Arkime in a production network? Starting the Arkime and let it run for 2 months will consume lots of traffic to be stored, right? So the question is, what's the strategy to deploy Arkime in a production network?
So I'm gonna, how about we save that and see if I answer it or not.
Okay. Okay, and I think one more follow-up here that just came in. So we can run Suricata and Arkime in the same box?
Yes.
Even in a large deployment?
Yep.
Okay.
I have no clue what we are anymore, but we are, let's say, at least a top 50 company. We're running large boxes with Zeek, Suricata, Arkime, and other tools all on the same box. We have multiple boxes, and I'll be talking about that. So, you know, if you're doing the 100 gigabits per second that you want to monitor, you will need more than one box if you want to run all 3 tools, especially Zeek. But you can use and I'll talk about this more, a network packet broker to load balance the traffic and run multiple boxes, etc.
Okay, great. No other questions at this time?
Right. Great. So one other thing I'll mention about this demo that Elyse just did is, you know, it's hard for us to get real live demos that people are okay to share. And so this one, we've probably shown this 2 or 3 times now, but I think it really shows off what we're doing. We don't currently have a Suricata, you know, demo that we can get everybody's blessing to share, which is probably obvious for most people why that is. But like I said, this is a great example. And just because it was Falcon alerting, you know, you can substitute Suricata or Zeek alerting for it instead, and you would go through the exact same flow. It's just that initial thing in this case happened to be Falcon. So I'm going to quickly show just 2 common deployments of our visibility stack. This is what an office deployment might look like. And when I say office, this is like your physical office, like you have offices around the world or around the country. We, for example, at Verizon Media have over 50 offices. All of them have this exact same setup where you have basically a 2-level system that's in an HA pair. So you have firewalls and switches that are HA paired, talking to the internet. And from those switches, which is what everything else connects to in that office, we have span ports that are sending a copy of the traffic off to the network packet broker. And the network packet broker, that's what the NPB is, will load balance the traffic off to the visibility boxes. And you'll have n number of visibility boxes based on the size of the office. You know, maybe if you have less than 300 folks in an office, you might only need 1. Maybe you'll do 2 boxes so that you have a failure redundancy. And then if you have like a large office, like let's say 3,000, you know, campus or 5,000 campus somewhere, then you're going to need more than 1 or 2 boxes. You're going to probably need 5 or 10 boxes, just depending on how long you want to keep the traffic and how much traffic there is in the office. And then on the bottom here, what this is showing is that somewhere you're going to have a VPN, and the VPN is going to be connected to something, and you can also watch that traffic too. So even folks that are working from home, you'll be able to see what that traffic is and monitor it. And you'll probably have different rules for an office deployment versus a data center type deployment or colo or cloud deployment. An office deployment, what we found is we usually want to keep the data longer. We usually want to run more rules. We want to just be more thorough because it's people's laptops that are getting attacked. They're getting rats on them. People are trying to do lateral movement through offices. Most folks are going after your employees first so that they can then get a stronghold in the production environment. So most of the time we find that people don't go directly into the production deployment. It's easier to get onto an employee's laptop. So a data center deployment will look slightly different, but similar in that usually you're going to use optical taps instead of a span port. Optical taps, guarantee that you're going to get all the traffic that goes by because it's actually stealing the light and sending that off. Where a span port, it's up to the switch to send the traffic. And if the switch is overloaded, the one downfall with span ports is some switches will stop sending copies to span ports. So if you're running in poorly scaled offices, you probably don't want to actually use span ports. You want to use optical taps there too. But if you're scaled well, span ports will still work. But in production, you definitely want to use optical taps. And usually, but it can be different depending on your deployment, you're going to have some kind of core router, or every company called it something different, but that's talking to your wave gear or maybe talking to your encryption gear. It just depends on your setup. But basically, right before it goes, quote unquote, to the internet is where you're going to usually want to put your optical taps. That's going to be where you see the traffic that's going places. It's where you're going to see it right before your wave gear encrypts it and sends it off. And in this example right here, what I'm showing is that most large data centers or colos actually run in some kind of HA setup where you have 2 comm rooms. And what you're going to really want to do is you're going to have optical taps in both comm rooms, forwarding the traffic either directly to one MPV, or in this case, if they're far apart, you'd have 2 MPVs and one MPV forwards the traffic to the other, which then forwards it to your visibility boxes. And again, you're going to have n number of visibility boxes depending on your traffic level. If you're doing hundreds of gigabits per second, you may have 10 or 20 boxes. It just depends how many or how much data you're doing. And the main reason that you have the 2 MPVs forwarding to 1 is because of asymmetric routing. If you're running in a large data center, a lot of times they have asymmetric routing where either comm room can receive data from, or receive the packets from the quote unquote internet, and you need to make sure that they actually all end up on the same visibility box, because tools like Zeek, Suricata, and Arkime all work much, much better if they see all packets of a session. And if you actually hooked up different visibility boxes in different rooms here, that would not always be the case if you have asymmetric routing. So what kind of hardware do folks use for visibility? So your MPV, you can go from anywhere from Aristas to dedicated folks like Gigamon, and there's everything in between. Elasticsearch, that's where Arkime stores its metadata. We get many cheap boxes that are storing 8 terabytes or more per box, and that's our database. You don't need the Elasticsearch boxes if you're not using Arkime. Obviously, if you're only using Zeek and Suricata, you wouldn't need that, but for Arkime, that's required. And then for visibility boxes, we recommend folks look at what are usually labeled as like big data boxes, and you gotta say big data. You want a lot of memory, a lot of disks. We happen to like 2 RU boxes instead of the 4 RU boxes, just because we can cram more of them into a single rack. We've used Supermicro Dells and HPs. All of them have 2 RU versions that can hold at least 24 disks. I have a picture of how that works. It's kind of magical. All of them work great. So how do you choose how many of these boxes you need? Well, really, it's just a bunch of math for PCAP storage. You need to take how much data you're getting on average and how long you want to store it for. And we actually have a web page, an estimator, that you can just plug in this kind of data and it will predict how many boxes you need of what size. But it really is just math around your visibility boxes. And you need to make sure you take into account Zeek, which is kind of a hog of resources. So if you're running a lot of Zeek things, you will need more visibility boxes just to handle Zeek's requirements. The advantage to that is that means you can usually get more PCAP retention, because the more boxes you have, the more PCAP retention you have. Suricata and Arkime both pretty much run quote unquote for free. They're fairly low resource when compared to Zeek. You know, if you're running a 7 gigabits per second box, you might need like 10 or 20 gigabytes of memory per Suricata and Arkime. And CPU, really just get any modern CPU and both can keep up fairly well with those. Elasticsearch scaling is a little bit harder. A lot of it is magic. There's a bunch of websites out there about how to scale your Elasticsearch. Again, our estimator page will make a prediction for you about how many boxes you need. The cool thing around Elasticsearch is it's easy to add and remove boxes if you find that you need to store more or less data. So you can make changes. Where visibility boxes are a little bit harder to make changes because you're getting, you know, the network feed and such. So it usually requires more interaction with your network team. So folks always ask me, how much does this visibility cost? I don't have budget and stuff. And what I'm going to share here is just what we do. And these are all kind of list prices. You can definitely, if you're a bigger company, you can definitely do much better than this. So really, there's not very many components. It's your drives that are going to be usually the most expensive. And in this example, using 12 terabyte drives, you can now get them for $300 or cheaper. You can get 14 terabyte or 16 terabyte drives if you want to build bigger boxes. It's really just up to you. You pay a slight premium for those now, but they're going to go down, obviously. In this case, we actually did 256 gigs of memory just so that we can run a sensor that's doing between 7 and 10 gigabits per second and has Zeek on it that's handling that and not going crazy. If you're not going to run Zeek, you can definitely lower your memory requirements by a lot. And so you can buy a generic box like the Supermicro, which is the one up top, for 15K or less these days, depending on how you configure it. The one issue with the Supermicro box is to get to that second row of drives, you actually have to pull the box out of the rack and unscrew, and it pops up. It's kind of a funny design. So in some ways you get what you pay for, but it's cheap. You can switch to a brand name type box like Dell and HP, and there's others now. They both have a similar design where the front drives actually kind of pull out and the box stays in the rack. And then that's how you access that second row of drives. You're going to pay for that. Usually it's about $5,000 more. And then they're going to want support. And so it's still going to be under 23K list-ish price for each of these boxes, but that gives you 240 terabytes of space. Now you could go with 4 RU boxes, and there's 4 RU boxes that have anywhere between 45 and I think they're up to either 72 or 90 drives. And so you could get a petabyte or more in a box, which is insane if you think about it. And you could have a lot of PCAP that way. Sometimes the ratio doesn't work out with CPU, especially if you're running a lot of Zeek scripts. But it just depends what you want to do. Definitely recommend testing around that. So now we're going to talk a little bit about Suricata and show some screenshots. So why do we think Suricata and full packet capture are important and go so well together? Well, really it's about the context. You know, Suricata, you can see the packets or whatever that caused the alert, but you can't always see the whole session, and you can't always see what happened around that session. Like, just because you caught that something doesn't mean you caught what happened before that led up to it. Like, maybe Suricata is catching like a dropper being used, but it doesn't actually catch it being downloaded. If you have the full packet capture, you can then, if you get an alert on something being used, you can go back and see if you can figure out, well, where was it downloaded from? When was it downloaded? And it's just super important, at least we feel, to be able to know that if you want to do a full, complete investigation. And then it really allows you to correlate what's going on in your network. Like, if you have a session that's firing because of an alert, you can find corresponding sessions that had that same alert easily and see the packets and see if they're similar and see what's going on. We have a bunch of visualizations that we'll show you a couple screenshots of. And we feel it just makes hunting and responding to alerts a lot more powerful, because sometimes you just want to go through and hunt through your data, which Suricata alerts is not necessarily the best way to do it. Now, you can use the other Suricata data flows or Zeek data flows to do hunting, but we feel actually having the traffic makes it easier. So what are the easy things that we do is in our SIM, which is on the right here, you can add right-click actions. Most SIMs have the ability to add a right-click action. And in this case, our operators added one that goes directly into Arkime. Now here it's still called Moloch. We've been doing this for so long, folks don't always update things right away, but it's the same thing. When they open up a Suricata alert in the SIM, they can then right-click into it and go directly into Moloch. And what it might look like when you go into Moloch is it shows the search results. And so here, what I'm showing is, let's say we went into Moloch, Arkime, even I make mistakes. Arkime, and we're searching for all Suricata alerts in this time range where the severity was greater than 2. And so I turned on the columns that show the Suricata category and signature so that you can just see what they are. I hid the IPs. Normally you would have IPs there, but for reasons, we hid the IPs here, but you can see all of the ones that match. You have a graph that's showing you when they're matching, when they're firing, and then we can open them up and see what they look like. And all the fields are first-class fields. So anything that comes into Arkime from Suricata can be searched just like any other field. So when you open up one of these sessions, like Elyse showed in the demo, there'll be a section that just says Suricata, and here's all the information that will be shown. Any of these fields you can click on, it will automatically add it into your expression for searching. And then if you click on the actual field names, you can get all the unique values. You can pivot it into other visualizations and such. We have a bunch of different visualizations that you can do. And this is a very simple one where it's basically just doing a table of unique values. And in this case, I sorted by the second column, the signature column, the counts. And so for the time range that I did the search for, you can see how many of each is firing. And so the first one, for example, was 1948. And why there's the first count column is duplicated because that's how many of the potentially bad traffics there were. And so it's a unique value for both, unique count for both values. And so you can add as many columns here as you want, or no, I don't think it's as many as you want. You can add several columns here and you can get unique counts and show this to folks.
It is now as many columns as you want.
Oh, awesome. Elyse is always adding features that I don't keep up with. Some of our future work with our Suricata integration is right now we require that Arkime and Suricata are on the same machine seeing the same traffic. And this can sometimes lead to problems where people want to have dedicated boxes for Suricata and Arkime and Zeek, and it makes sharing the eve.json between them not work as well. So what we want to do is make it so that either they can be on the same, they can be on different machines, or they can be in different VMs on the same machine and have it easier and work better. And so the biggest thing that we're going to do is to Arkime, we're just going to add kind of a delay that says, before you go query the eve.json, wait a few seconds in case it, it takes a while for the eve.json to get updated. And probably our most requested feature, which is a very simple feature, is people want to just be able to view the signature and rule for, what fired on here. Because sometimes you just don't have it memorized or know what each of these are, especially since, I think we're running over 70,000 of these. You can't know them all. And so we have a separate tool right now that makes it easy for the operators to do that, but we just want to integrate it and make it for anybody who wants this feature, at least. We can just see what the rule is and see why it fired. Arkime also supports other kinds of enrichment, just besides just Suricata. And so here in this example, threat stream is another provider of data or anomaly. And just like Suricata, we add all these first-class fields. In this particular view right here, we're showing all the unique values for those fields that we've seen. You can do this the same thing with the Suricata data set, where you can see all the different values for each of the fields. You can also enrich it with data that you have locally, that's not a commercial data source. The most common is you might have an IPAM or an IP database that you want to enrich all of your data with. So in this case, as every single session is written out, we can look it up in our IPAM database and add first-class fields such as what data center is it in, security zone, maybe we look up the subnets, what VLAN it is, all those different things, and add different fields in there. And this is just customizable per deployment of Arkime. So we'll pause for a second. And did I answer that question about a production deployment?
We'll give him some time to respond. Otherwise, I'll consider it answered. You have a couple more questions that came in. I thought now is probably a good time to ask you those. Okay. So this goes back to, I think, probably your deployment configuration. Is there a management server for Arkime, as in a centralized server to query 10 to 100 different Arkime servers?
So I'll answer that two different ways. If you're talking about like the UI, like this kind of UI, which of the Arkime servers it goes against all of them in the cluster. It can access all of them at once from the UI standpoint. If you're asking from like a administrative like orchestration system, no, that's up to each deployment to figure out how they want to do it. We personally use Ansible. I know people who use Puppet and Chef. There's all kinds of different ways to do it. This is something I always debate if I should have a slide about this or not, but because this is Suricata, I didn't put it in there. But if you're running open source tools, you definitely need more Linux-friendly administrators working at your company. And if you're doing commercial tools that you're used to just clicking buttons and such. And so like when we first started, I always said we were like a 0.1% kind of software where maybe only 0.1% of people should be even considering us, just because there's so much that you need to do. And then we've gotten better where like we're maybe 1%, and maybe now we're up to like a 5% of companies could actually consider using us. And I keep wanting to improve, but that's not necessarily something that A, we're good at, or B, want to do. And I know Suricata has some of the same issues where if you just run the baseline Suricata, you do need to know Linux, at least some. Now, obviously, there's other companies out there that are commercially supporting Suricata and Zeek, and maybe someday Arkime. that could handle some of that for you, but currently we're not there. But as far as the UI, yeah, they all go through the same UI. If you have multiple clusters, so each cluster can have multiple sensors in it, and then you can have multiple clusters, and you can search across multiple clusters with what we call a multi-viewer, which knows how to search across multiple clusters. It's the exact same UI. There's just one small difference where you can select which clusters you want to search against. And then it's obviously not going to be as fast because it's going to be as fast as your slowest cluster is. But you can have a bunch of different clusters. So we actually do that where each of our data centers is its own cluster, for example. And then if you want to search all data centers, you can also do that. But if you know what data center you want to search, you just go directly to there.
Okay. Oh, excuse me. I'll just keep going. Quite a few questions coming in. So how does Arkime work with duplicate traffic? Let's say from span port and decrypt TLS port.
Great question. So recently, I can't remember what version it's in, we did add deduplication. It's an optional feature that you can turn on because it does use CPU and a tiny bit of memory, but mainly CPU, but it handles deduplication for you. As far as between TLS and non-TLS traffic, if you're using a box where it actually uses the exact same ports and it's the same 5 tuple, there is a little bit of an issue. We don't handle that right now properly. What we currently do what we've done when we've tested that exact features, we had our MPB add a VLAN onto the decrypted traffic so that it looked different.
Okay. If you have Moloch and Suricata, can you use a single file to manage ET signatures?
So Arkime is not doing any signatures. It is just reading in the eve.json file that Suricata outputs. So it's not running those IDS rules. It's just if Suricata said something fired, it will then tag the session inside of Arkime as having that results from Suricata. So it's not implementing Suricata. So the short answer is, yeah, you just have one file because only Suricata is using it.
Right. Yes. And Suricata does create typically with Suricata update, which is one of the preferred rule managers. It creates a single file from the different rule sources as well. All right. Will the Arkime Suri distributed setup enable you to feed Arkime in the form of PCAP rather than requiring you to have it run on the network?
Yes, folks do that. It's a little bit harder. So if you're running them both off of PCAP, it's definitely a lot harder because you have to coordinate that. And that's one of the features where we want to delay what Arkime expects so that it can wait for Suricata to finish processing it before it processes it. So that doesn't work that great. If you're having Suricata or another tool write the PCAP and then Arkime is reading it later, then yes, that works fine.
Okay, awesome. Is Elasticsearch typically running on the same boxes as Suri and Arkime?
No, you can do that, but no, we prefer to run it separate, mainly because the visibility boxes and Elasticsearch boxes have different drive characteristics. Your visibility boxes, especially with PCAP, are just appending to files. They're 99.9% writes, and only when you open up a PCAP file is it a read. And so all it's doing is writing all the time, and you just don't want to lose any traffic or slow them down. Elasticsearch, is a database. It is constantly reading and writing. It's especially reading a lot more than you might expect because it's not like some of the other NoSQL databases where they only write. It's reading and recombining some of the Lucene indices into single files. It does that re-indexing constantly behind the scenes, and so it has a very high read-write output. I guess if you're using RAID cards and you had separate drives assigned to each, you could probably run them on the same box. But in general, we recommend you run separate boxes, especially for large deployments. Small deployment, you could get away with the same box.
Okay. You want to keep going?
Sure.
Okay. If you install Arkime in an environment that's already using Suricata and Zeek, can you use the existing data to search with Arkime, or does the traffic need to pass through Arkime before you can analyze the traffic?
You would need to reprocess the PCAP files with Arkime.
Have they worked? So this is a separate question now. Have they worked with PMACCT for NetFlow?
I have not.
Okay. And let's see, I've got a couple here in the chat. What operations and maintenance, excuse me, let's try that again. What operations and maintenance overhead does this require? It's hard to sell to my management. They feel buying an off-the-shelf solution is easier to maintain. So I think the question is about more general with all of the different open source components you were discussing.
Right. I mean, this goes back. So we have a Slack channel. Wish people would join it if they're interested in this. But I tell people regularly that if you don't have Linux people or support of your management, Arkime is not for you. It still requires, you know, an administrator that's watching your disks occasionally to make sure that they're not failing. You can automate it all. Ours is fairly well automated. We don't really have to do anything. But if you're used to pushing buttons and calling a vendor whenever there's a problem, Arkime is not the first open source tool I would start with. Maybe Suricata or something else would be a better tool to start with, but Arkime is definitely not the first because there are a couple different components, right? You got your Elasticsearch and Arkime, and you have to handle authentication, and it can be a little challenging from, you know, organizations that are not Linux friendly or open source friendly.
Okay, that's all of the questions we have right now.
Okay, I'll keep going real quick. So just real quick, what are we working on now? Well, the biggest thing we're working on is Arkime 3.0. The biggest feature of that is switching to Elastic Common Schema. So Elastic, about, I can't remember, 2 or 3 years ago, came up with kind of their security schema, and they hoped all the tools would switch to that. We had just re-schemed our own database like a month before, so the timing really stunk, but we've decided we're going to do it again so that we can at least map some of their fields so that it makes it easier for folks who are now using the Elastic SIM or just use Elastic for other things, that all our fields are named the same thing. The other big feature we're working on is WISE. WISE is kind of our intelligence gathering system. And we've added a UI. We're making it so that you can do all the configuration through the UI, so it's a little bit easier to deal with. Then we're always working on new visualizations and protocols. And cloud is a big focus for us this year. And we hope to finally have an official Docker image. There's tons of folks that have made their own Arkime Docker images, but we've never done an official one. Just real quick, the Elasticsearch recently relicensed. For most folks, this won't affect you unless you have a mandate from management that you only use, you know, true OSS approved licenses, which Elasticsearch no longer has, unfortunately. There is a fork that AWS and others are making that's in some ways kind of scary too, because AWS is behind it, but I'm hoping because they're bringing more people into it that it will remain true and kind of will be long-lived also until everybody gets along. And then finally, we eventually will have to figure out how we're going to handle these two kind of different forks of Elasticsearch, the true one and the AWS one. For now, and what we've done for the longest time is we only use the free features anyway, what used to be considered the free features anyway. And so we don't expect us to have any issues with this, but maybe eventually there will be some kind of fork where even the free features are different. And then our basic plan is we want to just support both for as long as we can, but when we'll have to decide when it actually happens. So if you want to get involved with Arkime, I mean, it is open source. We love to have people join our office hours in our Slack channel and ask questions and, you know, submit bugs. One of the things is, you know, Elyse and I are not security folks. We are, you know, software engineers. And so we don't always know what people want. Luckily, the Verizon Media folks give us lots of feature requests, but we're happy to work with other folks. So in summary, Arkime is a great open source full packet capture system. You can use it to search the sessions that are around any of the alerts that you have. You can use it to view and hunt traffic that isn't alerting. And it's open source. You can come and get involved. Thanks everybody for taking the time to listen. And if you have more questions, happy to answer.
Awesome. Yes, more questions have come in. So if gosh, excuse me, let's go ahead and just tackle those real quick. Packet captures contain sensitive data. How do you protect your Arkime environment? What security measures are in place to avoid unauthorized access?
Right. So great question. Arkime itself supports encryption of the PCAP files, and then you can also use full disk encryption, or you can use both. You can also use TPM with remote boot so that there's no operating system living on the boxes. So a great example of this is offices. Like if you have offices in countries where there's issues, you may want to look into using TPM on your box so it does a remote secure boot of the box, and then use full disk encryption on the drives that store the PCAP. And so that means that the encryption key is stored in the TPM. And then on top of that, you could use Arkime's encryption, where it's going to encrypt the PCAP file. So if someone got on the box, they wouldn't be able to directly access the PCAP anyway. They would have to be able to get the key. And so you have multiple levels of encryption there. It might be overkill, but if you're in a country where that's important, if you have an office in a country where that's important, that might be extremely useful. On the Elasticsearch side, really there's kind of two answers right now. There's full disk encryption, which someone gets on your box or uses the API, doesn't help you. And then there's a couple different startups. Titanium is one, and I'm blanking on the other one, that are actually working on encrypting the data in Elasticsearch. Titanium has a cool feature where the data is even encrypted to Elasticsearch. Like Elasticsearch, while it's running its algorithms, it's kind of obfuscated, so it doesn't even get to see what the data is also. So even then, the APIs can't return the unencrypted data. As far as physical access and accounts in the box, you got to lock them down. You got to use passwords, IP tables, or whatever your favorite flavor of that is. Yeah, you just got to be paranoid because it is an issue.
Okay, let's see, a couple more questions. What is the main advantage that Arkime versus Suricata brings? First stage packet analysis, metadata, PCAP storage in a better format?
I would say the major advantage is you can search on the metadata and go directly to that session quickly. Suricata, I am not a Suricata expert, so like I'm probably not the right person to give compare and contrast. I don't know if you can, Josh.
Yeah, we use, I don't use either in a production setting, but we use both actually quite extensively in our training setups. And Suricata, it's kind of surprises many people. It does do full packet capture. Of course, it can do alert generation, but it also has, in addition to that, the eve.json that Andy had mentioned earlier in the presentation has a lot of the traffic data as well, protocol logs, flow logs, and everything. And so that eve.json can get shipped right into, very common to get shipped right into Elastic and build visualizations over it. It doesn't have that native support though. And then as a user of Arkime, I'd say, it's just by far the easiest tool that I have come across for exploring that metadata, for pivoting off of any aspect of that traffic that's been indexed that allows you to do hunting, proactive threat hunting, or incident reconstruction. And so it's just a very powerful feature. But they both, I think, have their own sort of strengths or focus areas that aren't necessarily, they're very complementary, but not necessarily exclusive.
Right. Yeah, the only thing I mentioned or add is, Zeek and Suricata have that similar aspect where you can create the HTTP log and the TLS log, where it's decoding and saving all of that metadata to disk, but it's not necessarily linked directly to the packets. Yes, with community IDs and other features of the 5-tuple, you can get to the packets, but at least currently, the tools I've used don't make it as easy as Arkime.
Yeah, absolutely. It's awesome. If you haven't checked out Arkime, there's just a free demo. You can go right to the Arkime website and start playing around with it with some, I don't know what data you feed into it, but I mean, you can get hands-on with it right away. It's an incredible tool. All right, there was a question about an integration already being covered. I'm not sure what you're referring to with that question. If you're talking about the Suricata integration, I know there's documentation there. I'll look that up here and answer. Oh yeah, looks like maybe that is what they were asking. So yeah, there is quite a bit. I think, and Andy, correct me if I'm wrong, but a lot of the integrations that are supported by Arkime are covered in your documentation.
Yes.
Okay.
We're always working to improve our documentation. We've done a lot for 3.0 to make it even better. Elyse has done a lot, I should say.
And I'm not sure how to pose this question to you either. Long-time storage in metadata format exploration. Maybe that's a suggestion.
Right. So currently that's all in Elastic. What you can do is Elastic has the concept of multiple tiers of data where you might not replicate it. They've actually just released, I think, a way to kind of archive it off to AWS, Glacier, or something like that, and search it much slower, but search it that way so that your cost goes down. So you can have like your hot indices are on SSDs, and then your warm indices might move to hard drives, and then your cold stuff you can move off to AWS or somewhere else. But currently we're not planning on adding our own search where we could like export it from AWS, export it from Elasticsearch and somehow search through that. That's out of the scope. We like using someone else's database.
Okay, that's all the questions. We've gone a little bit over, so thank you both for sticking around. If anyone has any other questions, please feel free to put those into the chat or the Q&A. We will, as we are recording this, we will provide a link to the video. And Andy, if you're willing to share slides or not, also we'll link to those and get those posted within a day or two. I'll provide those links. We have a spot on the Suricata website. We'll also put them in our forums, and usually we tweet them out just for anybody that missed the webinar live. They can go back and check it out. I think that's everything we have. So thanks everyone for coming. Andy, Elyse, thank you so much for your time. It was an awesome presentation and a great tool. Again, I can't say enough good things about it, so I'll stop. If you guys have anything else you want to follow up on, otherwise I think we're pretty much ready to wrap up.
Nope, that's great. Thank you so much, Josh.
Yeah, thanks for having us.
Yes, anytime. Looking forward to joining your next office hours.
Please do.
I'll come and ask questions not about deployment and setup.
Sounds good.
Okay.
Thanks.
Okay. Anything else?
Nope.
Looks like we're good here. All right. Well, I'll stop the video and we'll wrap up. Where can we get a shirt? An Arkime shirt. I see the owl.
Hopefully soon.
Yeah, Andy made this one specially for me. So you can't have one like this, but we have a few black ones laying around, I believe.
Okay.
I'll have to look.
Yeah, not a store. There's not an Arkime store, is there?
That's a great idea.
Okay. All right. Well, thank you both so much again. And I think thanks everyone again for attending. So we'll wrap it up and everyone have a great rest of your week.
Thanks. You too.